these eruptions are enormous. The amount of material erupted from them, huge.
Natural systems can throw us a lot of curveballs. A lot of things can happen that we're not really ready for.
The carbon dioxide emitted by the Yellowstone magmatic-hydrothermal system has several properties that make it a significant gas to study, including its abundance, partial magmatic origin, and ability to provide information on the depth of the magma beneath the surface. Eugene Thomas Allen and Arthur Lewis Day, geochemists at the Carnegie Institution of Washington, discovered in the early 1900s that Yellowstone gases are abundant in CO2. In fact, CO2 is the most prevalent, more than 90% gas emitted from the Yellowstone magmatic-hydrothermal system, and estimations of the rate at which CO2 is emitted across Yellowstone show that it is amongst the greatest of any volcanic system in the world. A large amount of this CO2 is produced by the degassing of basaltic lava under Yellowstone. Lately, though, more and more individuals have been making preparations for the potential that this volcano will suddenly erupt. One can only picture the devastation if this volcano bursts. Will the volcano erupt as a result of the magma increase? Have the park's officials made the correct decision by closing it? Join us as we discover why Yellowstone officials recently reported an increase in magma beneath the park. Yellowstone National Park is a natural wonder, revered around the world for its natural beauty. Millions of tourists visit each year from all over the world to observe its unique surroundings. Visitors should, however, bear safety in mind while enjoying this wonderland. In fact, while visiting Yellowstone National Park, there are numerous possibilities to become wounded or even die. Throughout the region's history, there have been several causes of death, including violent conflicts between people, wagon accidents, falling trees, noxious gases, drownings, falling into hot springs, and, of course, interactions with wildlife. Even in recent years, news headlines have described bison gorings, tossing, bear attacks, and fatal falls from selfie moments gone awry. However, contrary to popular assumption, one of Yellowstone's most serious threats to visitors is not the plentiful and diverse animals that millions flock to witness, nor is it human error such as falls or road accidents. Instead, you're surrounded by a major potential danger: Yellowstone's hot, near-boiling hydrothermal fluids. While some of these thermal features can be seen on the surface, the fragile ground covers much of this geothermal reservoir of hot water beneath the surface. Surprisingly, despite the fact that falling into a thermal feature will almost certainly result in third-degree burns or even death, it is not often evident that visitors to Yellowstone's hydrothermal zones fully appreciate the grave threat of being severely burned. Visitors frequently disobey the plainly posted cautionary signs, leaving the boardwalk trails, which park rangers and park geologists set at a safe distance from potentially dangerous structures. Worse, as park visitors and social media usage increase, some people lose awareness of their surroundings and approach geysers and hot springs too closely for the sake of taking a picture. However, this lack of understanding and regard for the fragility of Yellowstone's thermal features is not a recent issue. Old photos in park visitor centres and hotels show some of the area's earliest European visitors standing on the unstable ground near the hot springs. There are also photographs of people and bicycles perched on the mammoth terraces, as well as ladies throwing handkerchiefs into the handkerchief pool. Although it is unknown how many visitors have been hurt as a result of ignoring the warning signs due to medical privacy rules, news reports of the more dramatic events reveal that the numbers are unexpectedly high. The number of deaths is far more concerning. Since the late 1800s, approximately 20 people have died as a result of some type of interaction with park thermal zones. This figure is much greater than the 8 deaths caused by grizzly bears during the same time period. Fortunately, if you follow the rules concerning wildlife and thermal zones, you can minimize these risks. Keep a safe distance from bears, bison, elk, wolves, and other wildlife. Stay at least 100 yards away from bears and wolves, and at least 25 yards away from elk, bison, and other animals, according to Yellowstone National Park. Stay on established boardwalks and take attention to signage indicating closures in thermal regions. It is not uncommon to find areas of unstable ground, some of which may conceal boiling water just beneath the surface. Even a seemingly innocuous stroll off the boardwalk could result in you breaking through thin crust and being exposed to boiling water or superheated steam. If your hat is ripped off by the wind and into a thermal basin, let it go. You, unlike a hat, cannot be replaced. So if you plan to visit Yellowstone National Park, be aware of the dangers and observe the rules that have been established to safeguard both you and these natural treasures. Thermal feature warning signals are not to be taken lightly, and no photograph or sense of fascination is worth the risk of serious injury. But by heeding park guidelines, you can ensure a magical visit to a place that is aptly known as Wonderland. Seismologists at the University of Utah recently collaborated with scientists from other universities to produce an image of the Yellowstone magma reservoir using a technique known as seismic tomography. They uncovered two magma reservoirs, one shallow and one deep, and that they are significantly larger than previously thought by thoroughly examining data from thousands of earthquakes. The study teams examined data from thousands of earthquakes to generate an image of the magma storage zone reservoir underneath Yellowstone. Seismic waves travel more slowly through hot, partially molten rock and more quickly through cold, solid rock. Researchers create a map of where seismic waves travel slower, providing a subsurface depiction of the hot or partially molten substances in the crust underneath Yellowstone. The deeper magma storage zone ranges in depth from 20 to 50 kilometers, containing approximately 2% melt, and is approximately 4.5 times larger than the shallow magma body. The study, published in the journal Science by seismologists from the University of Utah, the University of New Mexico, and the California Institute of Technology, investigates the magmatic relationship between the deep Yellowstone mantle plume and its shallow crustal magma reservoir. The research team used earthquake records from the Yellowstone Seismic Network in conjunction with seismic data from the EarthScope Transportable Array to gain a better understanding of the Yellowstone Volcanic Plumbing System, a network of seismometers that span the US. The Yellowstone Seismic Network uses closely spaced seismometers that produce images of the shallower crust beneath Yellowstone, whereas data from EarthScope seismometers produce views of deeper structures. The shallower magma storage zone is around 90 kilometers long, ranges in depth from 5 to 17 kilometers, and is 2.5 times greater than a previous, less accurate study suggested. Seismologists from the University of Utah and the Swiss Federal Institute of Technology published their findings in the Journal of Geophysical Research Letters in 2014. The magma reservoir includes 5 to 15% molten rock, melt, which fills pore gaps between solid, crystalline material. Although this is the crustal magma storage zone that has fueled Yellowstone's previous volcanic activity, magma does not normally erupt unless it contains more than 50% melt. It is worth noting that this shallow, low-velocity body extends approximately 15 kilometers northeast of the caldera at depths less than 5 kilometers. This shallow zone to the northeast is most likely caused by hot water, other fluids, and gases escaping from the magma reservoir's main body. This northeasterly migration of the magma system is congruent with the southwestern movement of the North American plate, which moves at 2.35 centimeters a year over a stationary plume of hotter mantle material, the Yellowstone hotspot, beneath 60 to 90 kilometers. The magma reservoir at 20 to 50 kilometers depth is a critical length in a continuous magma conduit that connects the mantle plume, at depths of up to 60 kilometers, to the shallow crustal magma reservoir at 5 to 15 kilometers. It also provides a far more thorough understanding of the Yellowstone hotspot's volcanic plumbing system and how magma and heat are moved from the mantle to the surface. To predict what to expect from a prospective Yellowstone eruption, scientists have turned to the last 3 known eruptions. The size of all 3 eruptions was tremendous. Approximately 80 comparatively non-explosive eruptions have occurred since the most recent large, caldera-forming eruption 631,000 years ago. At least 27 of these eruptions were rhyolite lava flows within the caldera, 13 were outside the caldera, and 40 were basalt vents beyond the crater. Yellowstone's most recent volcanic eruption, a lava flow on the Pitchstone Plateau, happened 70,000 years ago. In recent years, the frequency of earthquakes in the Yellowstone region has grown. Every year, Yellowstone experiences between 1,000 and 3,000 earthquakes. Some of these earthquakes are little tremors that go unreported. scientists can quantify the degree of activity in the magma pool below using some of the finest equipment for detecting and monitoring earthquakes. As the strength and frequency of earthquakes rise across the park, it may be an indicator that a new batch of magma is being injected into the magma chamber. It's difficult to say with certainty what these quakes signify for Yellowstone National Park. Nobody can predict what Yellowstone will do next. There isn't much else to say save the conclusions that can be derived from investigating the Yellowstone volcano's distant destructive past. Because of how long ago the eruptions occurred, evidence from previous Yellowstone supervolcano volcanic eruptions cannot be relied on to accurately predict what the volcano will do next. According to a Yellowstone National Park system alert, the massive dome-shaped rise is constantly rising in size. This is irrefutable proof of rising volcanic activity beneath the ground of Yellowstone National Park. Yellowstone officials have been forced to close the park as the volcanic uplift continues, making it inaccessible to visitors and even select researchers. This mini-lockdown was implemented to protect humans in the case of volcanic eruption, which appears to be closer now than it has been in the last 600,000 years. If a full-fledged volcanic eruption occurs, Yellowstone National Park authorities and the federal government may have to do much more than close the park to adequately protect the human population. Whole cities must be evacuated to protect human lives and property from volcanic eruptions like the one that occurred 600,000 years ago. While such a large-scale evacuation has never occurred before, in the event of a volcanic disaster, residents in neighbouring towns and even states may be forced to migrate far from the park. There is no assurance, however, that this will be effective. A huge volcanic explosion the size of Yellowstone will be so lethal that few, if any, states of the American continent would be spared. Let us know what you think in the comments section below.